Planck's law or Planck's Einstein relation. So Planck was the first scientist who who postulated the particle nature of light. He said that the energy of electromagnetic radiations are carried in packets. He named these packets as quanta or photon. So one packet is one quanta, and that is called a photon. So what is a photon? Photon is nothing but a packet of energy that is carried by electromagnetic radiation. He said that the energy carried by photons are not continuous, but it has discrete values, and it can be carried in integral multiple of packets only. So the energy of one packet, that is the energy of one photon, is equal to h into f, where h is called the Planck's constant and f is the frequency of the photon or frequency of the electromagnetic wave. Okay, because see, electromagnetic waves has dual nature. So it also has wave nature. So it has wavelength, frequency, but it also has particle nature. And for means the electromagnetic radiation consists of elementary particles called photons. Okay, he also called it quanta. So the energy of one such photon is equal to hf. This is Planck's law. So if there are n number of photons, then you will say that the total energy is equal to Ne. Total energy is represented by Q, and Q is equal to Ne, and E is HF. So because the energy is discrete, you cannot have 1.5 packet of energy or half packet of energy. You cannot have any energy between HF and 2HF. You will always have an integral multiple of energy of one packet. Okay. So now E is equal to HF. Now F can also be written as C by lambda, because you know that wave velocity in case of radiation is c, that is the speed of light, and c is equal to lambda f. So you will write f is equal to c by lambda. So you can here replace f with c by lambda, then you will write the energy of one photon is equal to hc by lambda, where h is this Planck's constant and the value of Planck's constant is 6.626 into 10 raised to power minus 34 joule second. But because in this chapter we'll mostly use the energy in terms of electron volt, that is why we will write this joule in terms of electron volt. Now 1 electron volt is 1.6 into 10 raised to power minus 19 joule. So 1 joule is 1 divided by 1.6 into 10 raised to power minus 19 electron volt. So this 1 joule can be replaced as 1 by 1.6 into 10 raised to power minus 19 electron volt. Okay. Now if you divide this, you will get h is equal to 4.14 into 10 raised to the power minus 15 electron volt second. So this is the value of h in terms of electron volt second. Now h is a constant, a universal constant. C is also a constant, the speed of light in a vacuum, and the product of h and c will also be a constant. Now we will remember the value of product of h and c. So the product of h and c is nearly equal to 1240 electron volt nanometer. So remember the units also. Hc is equal to 1240 in electron volt and nanometer, and it will be 12400 electron volt angstrom. So 1240 electron volt nanometer, and here 12400 electron volt angstrom. Okay, so the Planck's law is describing the particle nature of light, and it is saying you that the energy is discrete and it is not continuous. Energy is carried in packets, and you cannot have means you can only have an integral number of or integral value of packets. Okay, you cannot have energy between the two packets. Okay, now let us discuss some properties of photons. Now, a photon is an elementary particle which comprises the electromagnetic radiation. So basically, electromagnetic radiation is nothing but collection of particles, elementary particles called photons. Photon is the quantum of electromagnetic radiation. So we have already discussed what is one quantum. The definition of quanta, the word quanta means it is the smallest discrete amount of anything. So one quantum of electromagnetic energy is called a photon. So the plural of quantum is called quantum. Now, photons, or in general any electromagnetic radiation, has oscillating electric and magnetic fields. So the energy is stored in this oscillating electric and magnetic field. So photons are nothing but these electric and magnetic fields which are traveling through space. Okay. Photons are neutral, that means it does not have any charge. It does not have any rest mass. So it does not have any rest mass. It can have, it means it has moving mass, but it does not have rest mass. Now what does this mean is, listen carefully, photons does not have rest mass means that a photon can never be at rest. You can never find a photon which is at rest. Now, in general, for any matter, be it photon or any other matter, moving mass is always different from rest mass. Now, what is moving mass? Moving mass is equal to rest mass divided by under root 1 minus v square by c square. That means moving mass is always greater than rest mass. Moving mass is always greater than rest mass. Okay. Now, if rest mass is non-zero, so for any matter, you know that rest mass is always there. So if rest mass is non-zero, in that case you will say that we can never attain the speed of light. Why? Because if we have attained the speed of light, that means c by c becomes 1, 1 minus 1 becomes 0, anything by 0 is infinity. That means the moving mass becomes infinite. Mass cannot become infinite. That is why if a particle has some rest mass, it can never attain speed of light. Photons can attain speed of light because it does not have rest mass. Okay, so photons does not have rest mass, but it has moving mass. Okay, photons travel at a speed of light that we have already discussed. Now, how are these photons generated? Photons can be generated by numerous methods. Okay, we have discussed in electrostatics that an accelerating charge produces electromagnetic radiation. So photons are emitted by the action of charged particles, although they can be emitted by other methods including radioactive decay. So in the third chapter of this module, that is nucleus, we will study nuclear decay or the radioactive decay. In that we will see that gamma rays or electromagnetic radiations can be emitted during radioactive decay. Okay, now since they are extremely small particles, the contribution of wave-like characteristics to the behavior of photons is significant. Means this we will actually understand when we study the de Broglie's hypothesis. So de Broglie, or actually means in actual pronunciation, de Broglie is said as de Broglie because his name is pronounced as de Broglie. So de Broglie stated that we will discuss that later when we will study de Broglie equation. Okay, so uh, the next point is photons are often described as energy packets. Now, this we have already discussed. The photons are nothing but energy packets. This is a very fitting analogy as a photon contains energy that cannot be divided. You know that photons energy cannot be divided. This energy is stored in the oscillating electric field. These packets of energy can be transmitted over vast distances with no decay in either speed or energy. So now you know that photons carry energy. Okay, but it also carries momentum. Now, how to find the momentum of a photon? The momentum of a photon is found out using the famous Einstein's mass energy equivalence relation, that is E is equal to mc square, where m is moving mass of any matter. So here what we will say, m is, for a photon, m is moving mass of the photon is equal to energy of the photon divided by c square. You know that energy is hf, so it is equal to hf by c square, right? So the momentum of a photon is equal to the moving mass of the photon multiplied by the speed of the photon. The speed of photon is the speed of light. So m is equal to E by c square multiplied by c, that is E by c. Okay. Now momentum is equal to E by c, and E can be written as hf by c, or hf can also be written as hc by lambda by c. So the momentum of a photon is equal to E by c, and that is also equal to h by lambda. So you have to remember the formula for momentum of photon, and obviously also the Planck's relation, that is the energy of a photon. Okay, so this much momentum is carried by the photon. Now if photon carries momentum, then this means that it will also exert force on a wall when it strikes a wall.